This is question 16 of the product and quotient rule assignment. Find f prime of x and find the equation of the tangent line to the graph of f at x equals 2. So this is something new. We not only have to find the derivative, we have to find the equation of the tangent line at a certain x value. I'm going to rewrite this function so it's more conventional. 3x plus 2 times negative 2x plus 5. This is a product of two linear functions, so I'm going to write the product rule. U times v prime is vu plus uv. U is 3x plus 2, so u prime is 3. V is negative 2x plus 5, so v prime is negative 2. We'll put the whole thing together to get the derivative. I'm going to multiply this way. 3 times negative 2x plus 5 plus, because that's part of the rule. And then we're going to multiply this way. So I'm going to put in a little parenthesis there, negative 2 times 3x plus 2. If we distribute out, 3 times negative 2x is negative 6x, 3 times 5 is 15, and then negative 2 times 3 is negative, or 3x is negative 6x, negative 2 times 2 is negative 4. So if we collect like terms, we get negative 12x plus 11. I'm going to need the slope of my original function at x equals 2. So I'm going to go ahead and evaluate the derivative at x equals 2. Negative 12 times 2 plus 11 is negative 24 plus 11, which is negative 13. So my slope is negative 13. Our go-to for getting an equation of a tangent line is the point slope form. Y minus y1 equals slope times x minus x1. We have an x2, so that's my x1. What we don't have right now is a y1. So we need y1, so we'll have a point and a slope to use the point slope form. So I'm going to evaluate the original function at x equals 2. F at 2 equals 2 plus 3 times 2 times 5 minus 2 times 2. So that's going to be 6 plus 2, which is 8. And then negative 4 plus 5 is 1, so it's just 8. So my y1 is 8. Substituting into the point slope form, y minus 8 equals negative 13 times x minus 2. Now, most more conventional textbooks would just say that's fine for the equation of the tangent line. This book is going to ask for y by itself. So we can do two things. We can distribute the negative 13 and get this into slope-intercept form, or we can get the y by itself by just adding 8 to both sides. So y equals negative 13 times x minus 2 plus 8. And I'm going to put the two answers in, get the right answer, then I'm going to show you the workflow in the calculator. So we'll go here. So negative 12x plus 11. Check answer. Excellent. And then we're going to go with negative 13, then parenthesis x minus 2, then plus 8. Check answer. Fantastic. So now I'm going to show you the workflow in the calculator. So I'm going to put in the original function, parenthesis 2 plus 3x times parenthesis 5 minus 2x. And if I do 3x times negative 2x, that's going to give me negative 6x. So that's going to be a downward facing parabola. So as expected, downward facing parabola. Control dock for plus page, add a calculator page, shift minus to get a derivative. Our variable is x, tab to navigate through the template, f1 of x. So we get, they switched it around, but negative 12x plus 11. And then we need a point, so I'm going to evaluate the original function at x equals 2. So 2, 8 is our x1, y1. Now I'm going to evaluate the derivative at x equals 2. I could just backspace and put a 2 in there, but I'm going to show you the more sophisticated way to do it. Control equals to open the inequality palette, the such that bar, such that x equals 2. So I've got slope is negative 13. So I'm going to show you I can put this in as a point slope form. So I'm going to go back to the graph page, hit tab, delete to get the equals relation or equals erased relation. Y minus 8 equals negative 13 parenthesis x minus 2. And then I should have made this red, but we're going to go ahead and find the intersection menu 6, 4, lower bound, upper bound. So I do get a tangent point intersection at 2, 8. That concludes this video.